All right. So we're kicking off the presentations with the topic of observability. So in order to answer the question, what's happening in our system, we need to monitor and analyze operational data, logs, metrics, traces, also commonly known as telemetry. And Richard from Assist will delve into telemetry in the context of Axon Server. Richard, take it away.
Thank you. Hi, hello. Okay, so let me start. I'm sorry, this presentation will be very boring. I don't know why organizers put it really in the morning. Well, maybe it's a good idea because you are still fresh. So if you fall asleep, I'm sorry. We will be speaking about not about block cylinder architecture, but about cylinder or block cylinder block. And actually, we will be speaking about nothing more than some timers, some clickers, some relatively simple database, and finally, something that allows you to display the data. So nothing fancy, finally. Okay, before I start, something about my company. We are a Czech company. We believe that it makes sense to develop software in Europe. We have approximately 100 people, 4 teams. The representatives of the 2 teams of DevOps and Dev team are sitting here and will be speaking after the lunch. We are maintaining lots of applications and developing things around Java on top of Axon. Okay, something about me. I'm CTO of Assist, love Haskell, distributed systems, observability. Okay, when we started with Axon technologies in 21 with big applications, we've been using them even earlier, but with some big applications, we thought in 21 that CQRS and event sourcing and domain-driven design is actually the gold, why we are doing it. Well, in 22, we started to distribute it into microservices, and well, the easy microservices were the way or Axon helped us a lot with that. Well, in 23, we started to think about deploying the applications worldwide. So the location transparency with location awareness, which Art spoke about, brought us some ideas. And now this year, we are running a big application, so the telemetry is very important for us. Okay, but doing metrics, is it really a good idea? Well, there are lots of people who think that it's not a good idea. Well, nobody likes the messenger of bad messages. Even Zafar Bibelbrox had the special goggles that got blank if there is some risk. And even in metrics, they mentioned, well, not remembering things is a good thing. So deleting the database or having the metrics only for 2 weeks, thank you, is a good idea. I have also a quote from some very wise man, like what we observe is not the nature itself, but how it is exposed to the method of the questioning. Oh, from Allard, oh no, this actually happened before at another client. For some reason, they saw really weird behavior when something, and Andrei will tell you what. Also, think about that. The metrics, the amount of data that you are reading can be pretty big. Until the release 23.2.7, it was a big, because there was some issue with cleanup metrics from disconnected clients. So if you had lots of clients that have been reconnected, you were gathering lots of data that were of no big use, no big harm, no big use. Okay, also when you start, there is lots of technologies or lots of things that you have to learn. You have to learn the query language. There is plenty of different metrics from Axon Server, from Axon Framework, from JVM. Maybe you use Dynatrace, so you have to learn also Dynatrace. There are these counters, gauges, timers, distributions. Then you have to know something about statistics like percentiles, median. The sampling theorem, aliasing effects, dashboarding, you see it. Yeah, and then finally we realized that the last blocker was handled, And we realized that Prometheus has dark mode. You know, these young people, they are absolutely not willing to work with the light mode of application. So if application doesn't support dark mode, no go. So somewhere in February at the midnight, I sent to Andre this message, and next morning he said, okay, then it's a priority, and we started. Bit about the statistics. Look, these are the same data, absolutely the same data. This is 1 day of something. I'm not saying what, it's not that important. And someone might ask, what is the maximum value of the something? Well, is it 70 or is it 1,200? Well, it depends, but this is what you don't want to hear from someone who is responsible for telemetry and for observability for our system, because, okay. And, you know, this famous quote from Mark Twain, there are 3 kinds of lies, lies, damn lies, and statistics. Yeah, he was right. So I somehow convince you that the longer the time you use for averaging, the lower the value is. Or not? Okay, maybe the video will play. I hope it will. If not, okay. Sorry. This is a snapshot from our system. So these are real data. And normally, I would convince you that because the data are somehow regular, there are some 20 minutes batches, and if you are unfortunate with the averaging, you actually arrive to some aliasing effect, to some resonances, so you even have higher values than on averaging than without the averaging, because you are overlapping data in an unfortunate manner. So actually, not only that the statistics is complex, but you can also influence the data, how you present them, which is something that you don't want to do. Well, but finally, probably there are also some benefits of doing the telemetry, because otherwise there won't be such plentiful of nice tools like Grafana and Prometheus and the other. Well, maybe just because they are visually pleasant. Well, looking on the T-shirt, maybe we take some inspiration for the dashboards. So all of these graphs are somehow from some of our dashboards, and well, they are not nice to make people happy, but we have some color perception and we have some ability to quickly recognize patterns when we see them, and when we are well trained for those patterns, we recognize very well the patterns that the tiger is approaching, and we survive, or when the other tiger here is approaching. Okay, well, maybe not only because they are nice, or also because they are useful, that you can visually correlate data over each other. Okay, so these are some of the advantages that you get. You can detect regression, you can detect performance degradation, but I would like really to highlight one term which I really love, and this is mechanical sympathy. This is coming from Jackie Stewart. He was the Formula One, I suppose, racer. And he said that you don't have to be engineer to be a racing driver, but you have to have mechanical sympathy. And this means, in other words, that when you understand how the system is designed to be used, you can align with the design to gain optimal performance. But how will you do it if you don't see how the system behaves? If transparently, as Allard mentioned, everything somehow works, and you are notified or you realize that something doesn't work well only after you have some calls from unhappy and happy clients. Okay, so you start. You start with your Prometheus, and of course, you know that Axon Server is written in Java, it's run in JVM, so the primary suspect would be memory, because there is always problem with garbage collecting. There is always problem with memory leaks. Well, actually, it was pretty good, so we had configured our server according to specifications, and it just worked. So we are happy. But by the way, if you have some of your system monitored and they are written in Java, I suggest to use this memory usage after GC% and follow it, because this is the first line that is over there. And if it goes too high, well, actually, it's not good. Yeah, and then we stopped playing and start using some useful metrics or applying some useful metrics. Well, Axon Service, I don't know if I am allowed to say it, kind of database. Probably yes. There are data stored inside, so it's a database, no? So you have to protect the data, and one thing that might happen is that you run out of space. So, well, it didn't happen to us on production, and fortunately, so that, yeah, just take those metrics. These are just normal Java metrics, and it's good to have them there. And here you see some first reasonable metrics that you get from Axon Server. We have 3 applications, application A, B, and C. This is production. And here you see how the individual application, how the individual services are attached to the individual nodes. So if you see just one color somewhere, or some color missing, there is probably something weird happening, because that means that the applications are not connected to all the nodes. Sometimes it's correct because you just want it, because you have just 2 instances. But you have this information. So it is pretty useful. Also, you immediately see how many instances of your application work. This is, by the way, I think 90 days of our recent production run. Then you see those beautiful growing lines, and they are just saying how many events individual node has processed. And here you see for each application what is the last token of your context. It's useful to have them overlap, because if some color is missing, that means that one of the node is not, that the last token is not correct. Well, it didn't happen to us in production, but you just can follow. Yeah, the same data. It's probably good that you understand what is the derivatives and what is the primitive function, how you transfer the change, the growth, to the derivatives. So this is the last token here up, and here you see how the last token is. So how many events has been processed. So when the curve is the steepest, you have the highest value, just derivatives. And this is the same, just per node, and this is derived from last token. Again, just you quickly look, if something is fundamentally wrong, you see that the shapes are different. We are very good in recognizing shapes. Remember the tiger that we recognized in the savannah thousands of years ago. Okay, so let's go deeper inside, but before, let me say another thing, and the other thing is that we have to be focused on architecture, because if you want to have efficient observability team, they have to understand how the application is built. Maybe it is not that necessary on this BBC architecture that Allard mentioned, but on domain-driven architecture with CQRS and with those bit more complex architectures, the observability team just doesn't plug some observability tool to repositories, but they really have to understand what is happening inside. So if you have a chance, collocate your team. Have the dev, DevOps, and observability team together. You gain a lot. OK, and now another trick that we learned that is super useful. We somehow said look and see, or colleagues invented a new name, assessment for it. Just that is something weird happening on the dashboard, something unusual. And that's why it's good to have this device that records the history, so that you don't look on the data like that, but you look on the flow of the data, how they are changing on the curves. Well, we didn't do the backups very smartly. Not only it grows, but it was lots of data. And here we fixed it. There was an invisible bug in command handling. And but we are not observing command handling. We were just observing the CPU of the Axon server. And someone just looked, or someone, observability team, looked and saw, this is weird, this is atypical, there's something happening. It was Friday afternoon, this is weekend, and on Monday it was fixed. No animal was harmed, application worked perfectly, just there was plenty of things happening behind, and it would cause a problem. It didn't. The same here. We are observing some gRPC. Axon is using some weird technology like gRPC, and we are observing how many gRPC calls are there. This is a metric that is available. So we are just measuring it, looking on it sometimes, and evidently there is a problem. There was a problem with parsing of some file. Who would ever say that I will discover that there is a problem with parsing of file that was reparsed because of this? So we contacted our development colleagues and ask them, there is something wrong? No, not. So the question is, how many trains didn't crash or how many Chernobyls didn't explode simply because someone looked on some telemetry data and said, it's weird. So that's why I keep the record and compare with the history. Oh yeah, this is simple. When Ondřej installed first time the Axon server, he asked me, what should be the segment size of the event store? Well, I don't know. Keep the default. So we have three contexts, three applications, three big applications. 20 segments per week, one segment per week, one segment per 3 weeks. Okay, it just can change your backup strategy because all the sealed segments are backed only once. And here we have to bit less efficiently store the open segments because we have to have the history of the open segments. If they are closed, they can't change. So you have some information. Yep. Allard spoke about snapshots. Yeah. Here is a very weird thing. We have command handling, and it took up to 1.5 seconds. Unfortunately, I don't have the history somewhere here because we had this Prometheus installed that way that it deleted the all data. But trust me, it was growing from almost 0 to this few seconds, or 1.5 seconds mean. So it was visible here in the command handling time, but it was also visible in this matrix, file segments open total. So how many segments, and I calculated the rate over it, how many segments have been opened, those 256 max segments for the event store for one context. And we saw also that it's somehow growing, but there is even better metrics, which is called local aggregate segments. It's not really documented, but never mind. It monitors the number of segments that were accessed a reading aggregate event, or feeding aggregate event, I believe. And interestingly, for this context, here is something 285. And if you remember the previous graph, this was the same number of segments that we had in the context. So actually, it was reading all the segments. Well, probably the good time to start using snapshots. So yeah, from 1.5 seconds to 30 milliseconds. Just a small change. Yeah. Do we have serious leak here? This is also not that visible. So if you have a leak in subscription queries, in deregistering them, they stay there, and it's a bit tricky to handle it correctly. Well, resource management is typically tricky. So we just looked, and on the first context, it's already handled. On the second, we have some teeny tiny leakage, and our colleagues on the third application have already fixed. It's not yet on production. Axon Server can survive it. It's not a problem. Just that you waste your resources. So it's just good to look. Yeah. I mentioned the snapshot. It looks like the snapshot as well. We have very weird system. This system is fresh on the morning, but tired on the evening. Any idea? Increment sequence is the command, and is a command handling time of this increment sequence. Any suggestions? Well, think about it. I will just describe what you see here. So we are overlapping the average. So you divide the command bus success time second sum by command bus seconds count. So you have counter, timer, you have ratio of these two, and you have very nice average. This is how you should build your metrics. But from 10 minutes to 45 milliseconds, 10 milliseconds to 45 milliseconds, by the way, and here we have this max. This is coming from this, so seconds max, and you have also a distribution. So that means that you have these percentiles, and you have depends how you configure. But we follow the 50s, 90s, and 99th percentile of the data. Overlap them over each other. If they are over some measure, we change the color so that it really shows you. So any ideas what might happen? Why it's in the morning so good? It's based by date. So the sequence is, it's a sequence of some invoice or something like this, and the invoice is prefixed by the date. And then you do the counter. So we don't have the snapshots here, which probably makes no sense to make snapshots for that. So at the evening, there is more events. Well, and the aggregate takes longer to load. Yeah, this one is nice. We were thinking about how we detect that the application really works. So we bound it to command. We should bind it to event, but it's not that important. There is command duration seconds count, and the count says that it's not duration, but this is count of how many commands have happened. And this command is called checkout. Our application is kind of eShop. You probably understand that checkout is the most important thing that you want the application to do. And what we do is that we average over 7 last weeks. I don't know why my colleague chosen 7. She probably likes the number, I don't know. But there is average over 7 last weeks of the same period. So this is the gray one. And then we compare it, well, and multiply by -1 so that it's here down. And we compare it with the current data. And we say, well, very silly or simple heuristics. We are not, we just take care about the data that are somewhere from between here and here because of this 0.9, but it's not that important. And then we compare the ratio between these two values. And if the ratio is like weird, we trigger our alert and say, look, there is something happening in the application, which is the most important thing because, you know, if the front end doesn't work, you don't know it. You know it this way. You know it that there are no checkouts in the application. It's pretty smart. Oh yeah. Or you can give a feedback to your development team because they see there's too many events of some type. Here is this reference marked as urgent. I don't know the application that well, but I know that you have your basket, and you can say, okay, this is urgent for me. And if you have 20 or 50 or 100 of things that you are going to buy in the basket, and you push the urgent button, everyone has the event that this one has been marked as urgent in your basket, which is doesn't reflect the business case or how the business works. So Jaroslav have introduced a new one. This is mark all, and you see that we moved from here to there, and there is the introduction of the new event type. By the way, this is pretty useful. So if you have a chance, replay your event store, like completely, let's say, from 0 to those millions or billions of events, and observe. Because you can see the patterns inside of your application. You can see how it evolves. Maybe some events are happening more often than you expect, or there are patterns changing. And you can derive some data just looking. It's nice, colorful. Yeah. I was contacted by one of our developers asking. We didn't find why. We have 2 handlers for queries, and only one is being called always. Why is this happening? Well, I didn't know at the time, so we contacted guys from Axon, and he said, look, well, there is this famous version. We already saw the version once. There was lots of fixes. And since this version, this is distributed correctly. The bug was not that important because it happened only if you have your application connected to one single node, so the same node. So it was difficult to see, and in many cases it didn't cause any harm. It haven't even been visible. So this is the query, and this is how it looks in visually. Quickly, replay of several millions of events. The oldest event was 1.7 years old. The last event was 3 days old, and you see how the replay goes. Yeah, I will ask you then some questions, but the replay took 10 hours, which didn't make Jaroslav happy because he planned some deployment. So is the 10 hours good or not? I don't know. If you plan in advance and you replay in advance, it's good. If you don't, okay. Well, it looks better now. And now I will ask the questions. So it is the same, just in 45 minutes. A bit of fine-tuning, of course. Fine-tuning on a configuration. And you can reply aggressively parallelly. This is the age of the event. And you see that the curve is not monotonically going down. That means that you are replaying sometimes older events than you had before. Is it a problem? Well, it might be if your application is not well designed. But definitely, it's about how you configure your aggregate policy. So if it is sequential per aggregate, it's all right, if you count with it. So just be careful about that and count with it. And if you parallelize a lot, you can gain lots of speed. Question, why the last value is not 0? And was not 0 before. Well, I will answer myself because we are running out of time. It is because it was a snapshot of some few days old snapshot, in this case 8 hours old snapshot of the database. So the oldest event youngest event was 8 hours old. Yeah. Another thing that you can do is that someone comes to you and says, to Andrei, and says, you have a bug in your Axon, because he's maintaining the cluster. Says, okay, let's look on the telemetry. There are some errors in event digestion in Axon. I said, okay, let's look when you did the deployment and when the error starts to appear. Here is the deployment, here are the errors. Well, it answers the question. Oh yeah, you can get very quick overview of how your queries and commands perform. You just measure in the upper, you measure how many they were, so the rate, and here you measure how much time you spend there per second. I measure it in percentages, and if you see over 100, so it means that it takes more seconds per 1 second in 1 second. Oh, it's a bit complicated, but it means that it takes just longer. They are just more and more stacked there. They are not, because you have some parallel processing, you have more cores, you have more threads, and if it is, just sometimes, so it's all right. So the queue go down. But good to know and good to watch. Yeah. And you see that what we do for our client. Is it obvious? I don't think so, but okay, so let's go through it. First, we have alerts. Yeah, some value is over some other values. Then we have business metrics. I will show you how we build very nice business metrics thanks to events. Then we have the protocol. That means we have application built on WebSockets, so something about WebSockets, not Axon related. Then we have the deployments. This blue line means, or this, how did the break there, sees that there is a new deployment of the application. So you can correlate with the deployments and with the version of individual services. Then we have Mongo, because it's at Mongo, so some metrics from Mongo. But then it starts to be interesting. And we have Axon metrics from commands, events, and queries. And then we have all the applications for the given context, some details about them. and then we measure the downstream systems, that means that. Okay, so I will zoom in quickly to how we measure the commands, or how we measure the Axon server. One trick that we really love to do is this trick over averaging over certain period. Before we had over 7 weeks, now we set it on more realistic 4 weeks. So the gray line is, if I select, this is 3 days, I selected 3 days, and the gray line says, well, this is, I don't know, Monday, Tuesday, Wednesday. So this is Monday, Tuesday, Wednesday, week ago, 2 weeks ago, 3 weeks ago, and 4 weeks ago, averaged over each other. So this is kind of business as usual. And we comparing it with current data. So if the shape is different, you immediately see that it's different, and you immediately see that you have to react. It's up because we are actively deploying a new user, so our application is growing. Well, when these two will overlap each other, that means that we have saturated the market somehow. And, well, yeah, probably nothing more. You can see how many commands we do in the given period. So it's 100,000 commands. I don't know, 120, whatever. Not that important. But you have the numbers. You can compare the numbers. Those are the queries. Yeah, sorry for that. This is how we measure every service. So this one is one service. This is a query service. And what a query service does, it digests events and handles queries. Well, logical. So we see how many queries we handled, how many events we processed, and equivalent fail rate. You can just copy-paste after from the video or from my presentation that I will put publicly those queries. They are pretty useful. And for the command handlers, we have how many commands have been handled, fail rate, how many instances is running. So how many instances is connected to the Axon server. We know that they should be 2. So if there is something different, there is a different color, and we are alerting. How many events it emitted, and this is kind of, I don't want to go to the debate whether it is Saga or not, and whether Saga is the correct name for a process, and process is the correct name for Saga. But we call this Saga, not the Saga of Axon's framework. And this is how many commands the Saga dispatched, because command can emit command or dispatch queries, dispatch commands and dispatch queries. There is a nice trick, I will let you to study it after, about how you can correlate between the application ID and the source tag in the Axon server. So there is some regular expression, and you do some subquery, you see the ID, the container ID, and put it together, and then you can query it. Yeah, and these are the first business queries. Here I have to specially thank from my colleague to someone who renamed event store to event bus, because all the metrics needs to be double. Because if you have Axon framework version 4.9, it's event store. If it's 4.10, it's event bus. And if you compare the history, you see probably the trick. You see the trouble. So she was about to kill me, and Jaroslav, who deployed the new version, like everything disappeared, and you told me this is a minor release. No. So be careful when you rename your metrics, please. Okay, but anyway, you can have useful metrics from this because you measure number of events, order created or order created without, I don't know, whatever. And you see how many orders have been created just in time. You don't need any transfer into data lake and whatever other tool. I'm not saying that you don't need those tools. You need those tools, but for deeper analysis, but for quick review of what is happening, whether the application works and how it works, how the main business events are performing. Beautiful, isn't it? And again, you compare history for weeks with the current state. So what we have is that we have some events. Now we see that some of the events are not properly named and properly chosen. And we see how many orders we have created, what is the cart activity, so people putting things from the cart, removing things from the cart, how many users have been created, so new users, so user adoption, promotions and estimations. Not that important for you, very important for us. Yeah. Application architecture. I shown this picture last year. Not going to describe it, but this is our application architecture. It's pretty standard. We have 6 stereotypes that we are applying, and that's it. And we have Axon Server in the middle. But we have a dashboard that really reflects this architecture. So this is part of the dashboard that I shown you, and each application we know which type it is and what it should do, whether it emits events or consumes events, dispatch queries, and accordingly you see how it works, how many of them is running, whether there are some failures, there is, and the fail rate. Okay. We have some ad hoc dashboards. I will be pretty quick. Maybe the interesting thing is that we reply the events. This was the 10 hours reply. And we digest 600 events per second, or digest server send us 600 events per second. And it took 10 hours. This is here. And the capacity, maximum capacity of the queue was 78%. And we saw some 8 seconds maximum event processing time, which we also fixed meanwhile. And now we have 200,000 events per second. So 220,000 events per second being digested by the application just by configuration and one fix. But the fix wouldn't influence it that much because you see we went down from 8 to 3.5. Maximums, if you have max metrics, this is very sensitive to anything that just one event is slow or something like that. And well, I know that for you it's now just colorful something, but when the developers got used to this dashboard, they can very efficiently see how they improve the behavior of the application after they change the configuration or after they deploy some fix. Okay, now we have standard dashboards that we deliver to our teams. This is for the query side. This is for the command side. Yeah, here I would ask you why we have only one, but you will answer that there is only one thread for event processing. This is correct, but 2 threads for replying to the queries. Correct, this is how it is configured. Okay, and this is how our standard command dashboard looks like. And you see that you have the rate of each command, and then the 90th percentile of handling time and mean handling time and failed commands. And this is per aggregate. Well, aggregate is still a bit alive, so we have it split by aggregate, and every aggregate is this yellow line, and you scroll through it, and you just see if it behaves differently or not. 3 minutes, thank you. This is a detail of one of them. So you can see this you saw already. This is kind of detail of how we perform per command. The same for queries, and the same for third party. So still the same pattern. This is the adapter. When we call some REST, put, get, delete, you know those verbs, strange. Then we call them through the adapters, so that we have also data from Axon metrics. There, okay, to wrap it up. There are 2 kinds of metrics. One are coming from Axon Server and one are coming from Axon Framework. So maybe it's new information for you. Just look on the slide when you will have a bit of time, when you will be choosing which is better to use in which case. The Axon Server metrics have a big advantage that you just measure the Axon Server. And you had lots of telemetry just reading the /Prometheus, for example, endpoint of Axon Server. And you don't need to do the complex instrumentation of the individual service level. And it is not cheap also because it eats memory, because metrics tend to eat memory. Okay, thank you. Hope that I convinced you And you are not sleeping. It's just weird. Hope that I convinced you that the telemetry is the most important feature of Axon. Thank you.
Thank you. I believe we have just enough time for 2 questions, maybe? 3? We'll see. Anyone out there? Everybody was I was going to say traumatized by the dashboard. No. Enthusiastic about the dashboard.
Hi. You mentioned you had someone that was not very happy that the event store changed to event bus. So how many time do you have to make this dashboard? How many time does it take?
Well, it was first time, but it was a painful change. On the bad time is the bad timing, so that's why it was that's traumatizing. But yes, I know that Axon is improving a lot in the metrics, especially on the server. So they are advertising it. This one with something that slipped inside for the framework, and it was it was very unfortunate. For server, there is a kind of relatively good documentation, and there are deprecation warnings. So and well, if you are prepared, you can do also on a level of Prometheus the translation. So if you know it in advance, you can do on server renaming of the metric, which will help you to avoid such problems.
Okay, thanks.
Welcome.
I have another question. How do you develop the dashboards, or do you keep the definitions of the dashboard somehow in source version control or something like that?
Not yet. It's a JSON, so it's easy to do. What we do is that we are now in the maturity stage that we are just about doing it, or it's being prepared. One thing that we automatize is that we have, for example, the list of events and a list of commands and those configuration things. And Jaroslav's team is providing to SRE team a JSON that describes the application. So what they do is they have some, I think, Python program or whatever, I don't know. And they are translating it into the changes of the dashboard. So it's not manual fiddling with every new deployment of a new command or something like that. This is automatized.
So how do you check the dashboards? Is there a routine going through the top?
Yes, there is a routine. There is a first thing. There is a routine, and there is a 2 times a day quick gathering of the team with the SRE engineer. So developer engineers with the SRE engineer, which is extremely useful because you are getting feedback from the engineers to the SRE engineer, from the developer engineers to the SRE engineer about architecture or about changes in the application, and feedback about from them about something is going strange. And so there is a common or mutual explanation of what is that. So that's one thing which we probably will abandon as soon as the application settles down really correctly, because the application is freshly deployed, relatively freshly deployed in the wild. And second thing is that we have lots of alerts, but this is even more boring than that. So I didn't want you to spend much time about alerting. But Grafana allows you to do alerting. You configure some thresholds or some relations, and then you go to alert. We are getting the alert in the Slack. We read the Slack. My pocket is vibrating all the time here now. So yeah, we are getting this.
Thank you.
Yeah, I guess that's the end of the Q&A. Thank you, Richard, for a great talk.
Thank you.